Dearborn, Michigan. So, yeah, thanks to Alan Pryor and David and Giovanni, yeah, we are now familiar with the, all the backgrounds and the history of the PSD fatigue, right? So for next like 15 minutes or so, I will just talk about the more practical side of using that PSD fatigue functionality so that, yeah, what kind of button you need to click or what kind of keyword you need to use, yeah, that kind of thing I will cover. So, good. So first, I want to revisit the basics of the PSD fatigue. So in order to use the PSD fatigue functionality, for now, you need two input files. First one, just extract the natural frequency of your structure. So by using this one, you can extract the modes and the modal stresses. Here, you need to use the restart write option to make sure that that abacus run will write the additional output information so that you can restart on top of those modal stress extractions. And then if you have, sorry, going back. And if you have the multiple channels for the excitation, then you may need to use the secondary basis. So in that case, you should name those excitation points as the secondary basis. And if you have only one channel, then maybe the primary base will be enough. But in practical, in most of the general cases, you may need the secondary basis. Okay? So that's the key thing for the first input. And the second input, you will do the steady state dynamic analysis based on those already extracted modal stresses. Then this one will extract the generalized displacement, or in other words, a modal participation factor. Then, as Giovanni said, by combining those modal stresses multiplied by the corresponding generalized displacement, you can get the stress history of the structure in the frequency domain. Okay? Then in FE-safe, you can read in those two ODB files. For like a frequency extraction, you can specify there. For the steady state dynamic generalized displacement, you can specify there. And then you specify the PSD data, then FE-safe will combine those information and then construct the frequency range stress history of the structure and the duty cycle that structure is experiencing. Okay? Then you can specify the material data, and then you can run FE-safe to get the damage and the life estimation. So that's the basic workflow. And then in order to do that, you may need to get the PSD data, right? So you can use the external third-party signal processing tool, but we are providing a very nice tool so that if you have a single channel or the multiple channel time history, then FE-safe will construct the full matrix of the PSD data. So actually after this users meeting, I can share this presentation with all of you. so that you can just use this as a reference for the kind of step-by-step procedure of doing the PSD fatigue analysis. But here, you can start with the selection of the time history. And then if you select the frequency cross-spectral density matrix command from the menu, then it will pop up this dialog box. And if you specify the frequency rate of resolution and the analysis option, and if you click OK, then you will get the one big PSD file which contains all the information you need to define the duty cycle. Okay? And here, the key point is the order of selection. So when you select the time history, you should select by using regular Windows multi-selection scheme, like a control select. But that order is actually specifying the order of the matrix in the PSD. So that if you select in the order of, let's say, 1x, 1y, 1z, 2x, 2y, 2z, then your P00 is 1x, P11 is a 1y, and so on. So that is quite important because when you construct like that, then your SSD loading condition should also match with that order to make your duty cycle is consistent with your real loading condition. Okay? Then FE Safe, Safer Fatigue tool will construct this, this full matrix of the PSD. Okay? So I'm going to use this example. It is not that fancy, but I will use this example to show you how to do the multi-channel PSD fatigue analysis. So we have that simple structure, and then we have 4 loading points, and each loading point has the 3 channels of data. So altogether, it is a 12-channel excitation. Okay, so first of all, we may need to construct the PSD signal, right? As I showed you before, we can construct the 12-channel PSD matrix. That matrix should have a 12 by 12, and each one element has its own the PSD definitions, and then that order should be matching with your step setup for the steady state dynamic analysis. Okay, so again, you can follow these rules to give the secondary base name, and those base names should be matching with this determined loading schemes. Okay. So by using those 2 input files, you can get the modal stress and the generalized displacement from the abacus. Then in FE Safe, you can assign those 2 files through the that user interface and also the PSD file. Then you can follow the regular FE Safe fatigue calculation workflow to get the fatigue life and damages. Okay, so from this slide is actually more detailed description of the step-by-step finite element modeling procedure and also FE Safe setup. So next 10 slides is showing the FEA side, so that start with the part modeling, assemble and meshing it and assign the material. And then if you, and this is based on Abacus CAE, so if you are not using Abacus CAE, then you can ignore all of those 9 slides. But anyway, yeah, if you just follow that 1, 2, 3, 4, 5 steps, then you can create the frequency extraction step and output definition. And if you follow those click of the buttons, then you can create steady state dynamic step and output definition. And then that's the overall step definition you can see after those button clicking in Abacus CAE. And then you can create the primary base and the secondary basis in the frequency extraction step, and the secondary basis in the frequency extraction step. And then you can create a base motion so that you are assigning the proper excitation procedures, okay? And then you create a job, input file, and run those two files. Then you can get two ODB files. And there is some, a little bit of the investigation on the how we get the consistent or the reasonable fatigue life estimation. And some of that is actually due to the secondary base, due to the treatment of the secondary base. Abacus output always outputs the base motion modes first, and then sometimes, especially for the very flexible structure, you may have a little bit higher base motion modes frequencies. So in that case, you may have too severe damages due to that. So we recommend to exclude those base motion modes from the PSD fatigue calculation. So how you can do that? How can you do that? You can do either specify the minimum or the minimum and maximum frequency, so that minimum frequency is greater than the maximum base motion frequency. In that way, you can exclude the base motion modes from the calculation, okay? And then in FA safe side, you can just follow those button clicking to open ODB and the PSD data. And you can set up some unit system, or you can specify the group definitions. And then after you read in, these are the stress data set read in from the frequency analysis step, and these are the generalized displacement you read in from the steady state dynamic analysis. And you can see that I extracted 15 modes, and for those 15 modes, we have 12 channels of the generalized displacement. So those 12 channels of the GUs will be multiplied to these modal stresses to get the structural stress history in frequency domain. Okay? And then you can set a material, you can assign the material, and then you will see if you use Abacus ODB and the PSD data, then FE Safe will automatically set up the loading definition, so you don't have to do anything about that. Okay, and then output setting and analyze, then you will get the result. Okay, so in the afternoon, maybe we will talk about the post-processing a little bit, but yeah, when you do the post-processing of the fatigue life, you'd better turn off the averaging scheme of the your viewer, and then you can get the correct life estimate. Okay, so that's the overall procedure of doing the multiple channel PSD fatigue. And in case, on top of the multiple channel, if you have a multiple blocks, then you can, only thing you need to do is just specify the multiple PSD data corresponding to each block, okay? Then FE-Safe will automatically take care of those. And I will show you some examples of doing the multi-block and with the multi-channel PSD data. And this is one example that on the left you can see the just the single block 3-channel PSD analysis, and this is the just the example of full block of the 3-channel PSD on the same structure. And if the blocks are exactly same PSD, then you will see like a 1/4 of life from the left. But in this case, I'm using all different PSD blocks. So the single block gives us, even I cannot read that number, but 2.3 something, and the multiple block gives us about 1.2 something. Okay? And this is, in case of the multiple block, we can actually extract the, what are the damages due to the each block of the PSD loading. Okay, and this is another different structure example. And when I started with this talk, I showed you that we need 2 input files. And that is no longer true in FE-Safe 2017. And when you use Abacus for the PSD fatigue, you can actually run with just a single file. That's the new implementation in the FE-Safe 2017. So this slide just compares the slight different user interface between the FE-Safe 2016 and the 2017. Okay? And we have a new capability in 2017 so that you can use the combined Sure and normal algorithm in 2017. Okay? And I also tested with the, this kind of simple toy problem to compare the, all the algorithm available in FE-Safe 2017, that it shows the quite consistent results. Okay? And then, so yeah, based on the whatever we investigated, we can do the single or the multiple channel PSD fatigue analysis. And then the key message I want to give you is the order of multiple channel PSD and the step definition should be matching. And also the base motion mode, you the better extract from the analysis in order to get the reasonable damage results. Okay? With that, that's all. And I will give mic to my colleague, Ashan. Thank you.